Hi, 8th grade. Today we're going to start lesson 8.4. We're going to split this lesson into 2 days, and my goal for you for today is to split the first portion into 3 separate videos. For the first video, we're just going to talk about what graphing rational functions would look like and all of the rules, because there are quite a few rules that you would need to know and understand before you can start graphing. So first of all, the difference between a rational function and a reciprocal function from yesterday. What's different for today is that we're going to actually have a variable or polynomial in both the numerator and the denominator. Or if there's only a polynomial in the denominator, it's not going to be linear. So here's a review of what yesterday's looked like. Today, we're going to be looking at where a numerator and denominator could be a complete polynomial. There's not going to be A, H, or K rules for these. Okay, the vertical asymptote is going to work the same. The values of x for which the function is not defined or the restrictions, so we'll look at the denominator, set them equal to 0. What is different though from yesterday is that we can have more than one. Okay, that means your graphs might have 3 branches. The horizontal asymptote would have at most one of those. So here are your 3 scenarios. If the degree of the numerator is bigger than the degree of the denominator, there's not going to be a horizontal asymptote at all. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is going to be the x-axis. And the third scenario, if the degrees are equal, we have to actually look at the leading coefficients of our fractions, and that's going to be where your horizontal asymptote lies. Okay. So here are some examples to match up with these rules. The first scenario, where the degree of your numerator is bigger than, gizmo's in the way, the degree of the denominator, your vertical asymptotes, whatever makes your denominator 0, which would be -1, you would have no horizontal asymptote because this matches up with the first rule. The second scenario here, the degree of our numerator is less than the degree of the denominator. We have a degree of 0 over a degree of 2. Our vertical asymptote works the same. Set this equal to 0, which I have some work here. X squared minus 1. Set that equal to 0, take the square roots. Our horizontal asymptote, matching the second rule here, would be the x-axis. And the third example, notice our degrees are both a degree of 1. So we look at our coefficient of our leading coefficient. So we have a 2x and a 1x. So 2 over 1 would be those leading coefficients. So our vertical asymptotes, what would make the denominator 0? We only have one of those. Horizontal asymptote is going to be at 2 over 1 or 2. All right, so here's a note for you. And I have a separate little note off the note that says, see the textbook for some unique examples. The graphs can take many different shapes for these functions. We will be focusing on some of the more common shapes. Some are even going to be symmetrical and might look like hyperbolas. But we could see some shapes like these. So these first two, we have 3 branches to our graphs. The second one here, we have what's called an oblique asymptote, which I'll refer to here in just a moment. Okay. One thing I want to point about your horizontal asymptote is when you have 3 branches to your graph, the middle portion might not abide by the horizontal asymptote rule, but the outer edges, the outer branches always will. Okay, so some graphs also have an oblique asymptote, like I pointed out here. This happens whenever the degree of the numerator is exactly 1 more than the degree of the denominator, and they have no common factors. To kind of describe what an oblique asymptote is, that means it's a diagonal asymptote here. And then another note, you want to factor when you can, just like in lessons 8.1 and 8.2. If the numerator and denominators have a common factor, a special graph is going to form, and this tends to be the students' favorites because it's something we've graphed for a very long time. Often they will simplify down to a linear equation, but you would end up with a hole somewhere in that location. So we'll talk a little more about that when we get to that example. Okay, so those are your introductory and rules. So I'm going to stop this video there, and we'll pick up with example 1 in the next video.